welcome everyone. This is Dr. Heike Bielek from Into Infinity, and in this episode I'm going to explain to you how chaos can become order. So how does the chaos game work? Well, it's pretty simple. You have a triangle with, let's say, A, B, and C points. Then you have a point outside of the triangle, and it really doesn't matter where it is. Let's say it could be here. You roll the dice and you choose one of the points, A, B, or C. So let's say you go A, you take a projection here and you just go halfway. Then again, you choose between A, B, and C randomly. Let's say it's C, then it goes halfway again. Make a dot. Let's say it goes again A, maybe then it goes to B. And you see, the longer you play the game, the more dots you will create. Well, if I play the game infinite times and it's gonna happen randomly, the triangle at some point will be full. No, that's not the case. What comes out of this is a very intricate geometric pattern called the Sierpinski fractal. The dots will only appear within the upside triangles, and the upside down triangle is the space where the dot won't appear. So it will aggregate more into these upside triangles, which again will be divided always in the same pattern, and then it divides again, and it will just create an infinite pattern of the same triangle. So the Sierpinski triangle came out of the so-called chaos game based on a triangle. But what happens if you're using different kind of shapes? So let's say we're going to take a square, A, B, C, and D. And we're going to play the game again. So you have a dot outside, and you choose A, B, or C, or D, and then again the dot will move halfway. But what happens if you play this game infinitely? Is there going to be another fractal pattern? No. This time, there won't be a fractal pattern. It's just going to be one big filled square. So we won't have the same pattern when the dot moves halfway. But what if we extend the game now and we say, okay, let's add in another rule. And we're just going to place something in the middle. I'm going to place a little square in the middle, yeah, like that. Once it hits the center, it doesn't count. You have to roll the dice again. All of a sudden, it does create a fractal. This image in the middle is somehow reflected on the four corners of the square, and this is called the restricted chaos game. We're going to see more why this is so relevant when it comes to the reality experience itself, and what happens with those four corners of the Earth. So, is the chaos game only restricted to the triangle and not to the square? And when do we actually create this fractal pattern? The Sierpinski fractal happens with every single shape. The only difference is every shape has a certain sweet spot. So when you use a triangle, for example, the dot needs to move halfway. So the ratio here is 1/2, 0.5. With other shapes, like the square, it has other sweet spots. The pentagon, for example, has a sweet spot very close to the golden ratio. There's a very beautiful program online that you can try out and just play around with the ratios and see what kind of patterns emerge when you play the chaos game with different kind of shapes and different ratios. So let's recap on the idea of the chaos game. You have A, B, and C, and you got a dot that will always move. Randomly, chaotic, because you don't know which of the points it will choose. And what happens over time is the more dots you create, it will not fill the whole triangle. In fact, it will create a fractal pattern called the Sierpinski triangle. And that really reminds us about the octahedral structure of space. So this is the octahedral space that we explored already in terms of, the noble gases of the periodic table, those atoms that won't react, they're just completely stable. And what you can see here, this is argon, element 18, and it actually follows the pattern of the Sierpinski triangle. So you have a triangle upside with an upside down triangle, and the upside down triangle is actually the space. So really, when we're talking about the Sierpinski fractal, the chaos game, it relates to the octahedral space found in the atomic blueprint.